Alright, hey guys, my name is Vernon. We're going to be working with polymers today. We're going to do a cool little experiment to show you what polymers can do. For this experiment, we're going to be using sodium polyacrylate, which is a super absorber. So it just absorbs water and a lot of it too. But before we do that, we're going to kind of break down what a polymer is. We're going to explain a little chemistry. So the first thing we'll talk about are atoms. Atoms are unimolecular species. So like an example of an atom would be chlorine or sodium. Then you can use atoms to build larger molecules, and molecules are just basically an arrangement of atoms. So like, for example, we have water. It is a collection of 2 hydrogen atoms and 1 oxygen atom. And then you can use molecules to build larger molecules called polymers. And polymers are just chain-linked larger molecules. You kind of can like fuse them together to build long chains of a molecule. And sodium acrylate is our example of the polymer we're going to be using today. Another example would be like styrene. Styrene is basically known as styrofoam. So you can put it into a mold or something like that and apply heat to it, and it kind of decomposes and you can build a polymer out of it. So that's a little bit about that. And for our polymer, sodium acrylate, it is a very well-known super absorber. It can absorb up to 800 times its weight in water, and it does this through a process called osmosis. So on this polymer, you have a sodium ion, and what it does is it diffuses through water by osmosis, and as it diffuses, the water will surround the super absorber, and that is what essentially makes it absorb water and make it a good super absorber.
Hey guys, my name is Madison. Today we're going to be working with sodium polyacrylate, and we're going to explore some of its properties and see how it reacts with water. So grab your goggles and let's get going. Okay guys, so I've got 6 ounces of water here, and I've got some sodium polyacrylate, and I'm going to add it to our water, and I'm going to swirl while I'm doing so in order to get all the sides to react. And we are going to see what happens. So as you can see, the sodium ions have left, and it allows the water to completely engulf the polyacrylate, forming this very viscous material that kind of looks like snow.
So babies are pretty gross, right? That's why we stick these diapers on them. So fun fact about these diapers, they actually have sodium polyacrylate in them. Essentially, they function like this. When the baby makes an accident, the sodium polyacrylate in the diaper actually absorbs that fluid, resulting in a dirty diaper, but no urine getting on your clothes. So let's say you wanted to get your sodium polyacrylate back. Well, there's a special process for that.
We have placed our sodium polyacrylate and water mixture on an aluminum trail. We also put salt on top of it to be able to recover our sodium polyacrylate. This is possible because the ion in the salt bonds with the sodium polyacrylate, freeing the water.
Form, and then we're going to replenish the sodium to the polymer, and it's going to allow the water to leave the polymer.
Polyacrylate, we get this viscous material that is resistant to flow. Welcome to Dairy Queen.